So, my dear students, my name is Abhigyan Tiwari, working as an assistant professor at SITS Bhopal. Today we are going to learn deterministic finite automata, and today we are going to uncover this topic, Introduction to Finite Automata and Deterministic Finite Automata, also known as DFA. So my dear students, we are going to see this finite automata, which is known as Acceptor. So I will let you know why it is known as Acceptor. Let's try to understand this finite automata. Okay. So this is a finite automata. So let's suppose that this is a machine. Okay. And we have states here. What kind of states they are? It includes initial state and final state also. And let's try to understand this. So this will become initial state. And what is this? This is a machine. Machine means this is an automata. So machine is nothing but this is an automata which will going to take input from here. So we will going to give it input in the form of 1, 0 or ABCD, whatever be the thing. We are going to give input here, and we are going to get output in terms of yes or no. So see, this is an initial state, this is a final state, and you can say these two as an intermediate states. Okay. So whatever the input we are going to give in this machine, the state should be finite. The state should be finite. Okay. And automata means this machine is going to work automatically by taking some kind of input, and it is going to give you output. If by reading this whole input, and if we reach to this final state here, it means this string will be get accepted by this machine itself, and we are going to get output what? This yes. And if by taking this input we are not able to, by taking this input, if we are not able to reach to this final state, somewhere we left here, so we are not able to reach to this final state, we are going to get what output? This is no. So this string will not going to accept by this machine. So we have number of state, it should be finite, and the machine automata is what? This is a machine which will work automatically. Okay. So if this string will be get accepted by this machine, we are going to get yes, and that's why this machine is known as what? Acceptor. Good. So it comprises of input tape. Definitely we are going to take input from the user, and it will be reside, and this is the input tape where we are going to give input. Right now we have just 0, 1, 0. That's all. And again, what we have a reading head. Definitely through the help of that head we are going to read this input, and again we have this finite control. Finite control is what? It is in brain of that machine itself. So this finite control is responsible for deciding that after reading an input at which state we are going to move. And definitely FA has no memory. FA has no memory. Good. So in DFA we are going to get no memory. It is having no memory. Okay, now FA reads input string from left to right. Okay, definitely we'll start to read from left to right. We'll move towards this direction. Okay. And definitely we are not going to write on tape itself. This is an input tape. This is an input tape. We'll see the example. So we are not going to write on this one. Okay, this is an input tape. We are not going to write on this one. And if, see, what is the meaning of this one? If we reach to the final state after reading the string, then what will say? That string will be get accepted by that machine. Okay. And definitely the next state always depends on present state and present input. At a state, what kind of input we are giving to the state, it completely depends. Then only we can transit from a state to another state. Okay. So let us suppose this is an state Q, and after providing input A, we will move towards state P. Good. So there is only one next state for a given present state and a given present input. Definitely in a state, if you are giving an input, we'll have a next state. Okay, so there will be only one next state. Okay, so for let us consider this one. In this state Q, if we'll provide A input, we'll move towards P. It is not possible right now to give A and move to another state. So this will become not possible. Okay, so for B, if we'll provide B, then it can be okay. We can move to other state also. So for in a state, for a single input, we have a single output state. That's all. So FA accepts regular language type 3. So we have Chomsky hierarchy through which we can distinguish different kind of languages. So for different kind of grammar, we have different kind of languages, and for different kind of languages, we have different kind of machines available which is going to accept that language. So we have type 3, type 2, type 1, type 2, type 0. So later we are going to see, when we'll see that Chomsky hierarchy, we are going to learn this one, why it is known as type 3. Okay. So right now, regular languages are accepted by finite automata. Okay. And definitely FA is also called deterministic. Why deterministic? So deterministic means in a single state, for a single kind of input, we'll have a single state itself. That's why it is known as deterministic. Okay. Finite means number of states are countable. That's why it is finite. Automata means it is going to work automatically by taking the input. It is going to give you the desired output. And that's all. That's why it is known as DFA. Okay. Let's try to understand whatever we learn here. So this is a finite control. This is the brain, which is initially at state Q0. It is clearly visible here. State is Q0, and it is going to learn this A itself. Okay. After taking input as an A, this A, it decides what it decides. It decides to move right side. Okay. And the state will become Q1. So it changed its state from Q0 to Q1 after learning that A. And right now what is happening? It is in a state Q1 and it is going to learn B. And after taking it again changed its states from Q1 to Q2, and at last but not the least, it learns that B, and after taking as an input this B, it reaches to its final state. So that is how this is an input tape, and this is the reading head, and this is what finite control. So in a state, for a single kind of input, we have a single kind of output state. That's all. Okay. So we have formally DFA can be defined by using this 5 tuples which is written here. So before seeing this one, again I am repeating the same thing, that is DFA. What is D? D is for deterministic, and that is what in a state for a single kind of input we have a single output state or intermediate state it can be. F is what? Finite. It means number of state will be going to be finite, and automata is what? Automatically it is going to work that machine. We are talking about machine. So we will have to provide only input and it is going to give us that output in terms of yes and no right now. That's all. So what are the 5 tuples? So we have Q. Q is a set of states. So by using this 5 tuple we can define a DFA. So Q is the set of states. Sigma is the set of input alphabet. Definitely it is going to be a set. And delta. Del is the what? Transition function. So it is a mapping of set of states with input alphabet. It means we'll have to take the Cartesian product of that one, and it is going to map with what? Again, state. So this is a function, and that's why in function we are going to give some kind of arguments, and that is for input, and we are going to get the output. So what does it mean actually? Actually, see how we are going to define. This is a state, and the name of the state is what right now? Q. So by giving an A, that's why it is called transition. It means we'll have to transit from one state to another state. Okay, so in state Q we are going to give input as an A, and we are reached to P state, and that is the meaning of this one. So this is what Q is a state. It means it belongs to this Q. This is what A. A is what? Input, and it belongs to this one. Again, this will going to map is what? This is Q. Again, this P is belongs to this Q. So this is what the meaning of this one. Okay. So Q0 is the initial state definitely, and F is going to be the final state. So remember that we can have more than one final state. Okay. Good. So let's see. So a string X is said to be accepted by a finite automata M if Q0 X. X is what? Here X is a string, not a single input. We can give a number of alphabets also. So that can be a string also. So it can be a string of 0, 1, 0. So we can give a single alphabet, that is 0, or we can give 0, 1, 0 as a string also. Okay. So by reading this, we can reach to a state also. That can be a final state. Okay. So that string X will be what it will be called as an accepted by the machine. Okay. So the language accepted by M. M is what? Machine. Is denoted by language of that machine. So we have used a set builder form. So X. X is what? So by reading some X, we can reach to the final state. Okay. Then only this X will be called accepted by this machine. And this X is what? The language of this machine itself. Okay. So let's see this one. So del QA equal to P and del QB B. P is a valid. So let me draw this one logically here. So we have Q, and after reading this A, we will move towards where we transit to P. Okay, this is possible. Okay, so from Q again, by taking in another kind of input, that is B, we can move to where? We can move to P itself. So again, this is not required, so the state is same, so we are not going to this, we are just going to move this here itself. So that is what we have a P state, so we are going to take this area directly, need not to make again a same state. So this is B, and you can write again like this one also. This is also valid. So for A we have P, for B we can have P. Okay, but for A we didn't kind of different states. Okay, so that is how this is true, and this is how this is false. Okay, so see, let's try to understand this one also, the second one. So we have this Q, and for A what we have P1. It's good, but for same input A we don't have different state. So see, this is not deterministic. For Q, after reading A, where will I have to go? P1 or P2, and that is how this is called non-deterministic. So in DFA we are talking about deterministic, that's why it is not acceptable. Okay. So we'll see that the pictorial notation that we are going to use for making a transition diagram here itself. Okay. So in transition diagram we are talking about this transition, that is del function, that is after reading Q, after a state Q, after reading A, we will move towards P. So the notations which we are going to use, this is for initial state, a circle, and our arrow mark is there. See, our arrow mark is there. So this is for initial state, this is a notation. For final state we'll have two circle. And what is this? Q0 is the name of a state. You can write anything what you want, but this is the notation that we are going to use. Okay. And this is what transition on input. We have seen this one. This is Q is a state. After reading this A input, we will transit to P state. Okay. So more than one input is also possible. So these are the different kind of input. So for different kind of input, we can reach to same state itself. This is valid. And the transit can be in the same state also. That is a self loop. Okay. So if we'll have to write the transition function for this one, how we are going to write? This is del, this is what, q. After reading a, we are going to get what state? We are going to get same state. So this is how we are going to write a transition function for this one. Okay, so thanks for watching this video, and in my next lecture we are going to see that construction of DFA. Okay, so hope you have enjoyed this video. So thanks for that one.